Good morning, everyone. It's a real pleasure to be presenting here and to share something we at BeeARD are incredibly passionate about: autonomous science. So it's exciting to talk how AI is not just accelerating science, but beginning to shape the way we think about the discovery itself. I'll walk you through some of the theory behind autonomous hypothesis generation, explore current approaches in the field, and share more about what we have been building with BeeARD. Then, without further ado, let's start with something fundamental by defining what a scientific hypothesis is. To simply put, a hypothesis is just an educated guess. It's a testable statement about how the world works, and it can be based on observations, prior knowledge, or existing theory. It's the starting point for experimentation. Hypotheses are the engine of scientific discovery because asking the right questions fuel finding the right answers. And many breakthroughs in the world, in the scientific history, happen because somebody asked, what if? However, nowadays, the process of scientific discovery is faced with unique and mounting challenges. I think the most important aspect is that we are experiencing an information overload. So, according to research, in 2022 alone, approximately 3.3 million scientific articles were published, making it nearly impossible for researchers to stay updated on every relevant development. But we are also limited by our own biases, and this process is slow and often relies on chance. All of these issues collectively lead to missed opportunities. Significant connections between research findings may remain hidden across disciplinary boundaries, creating so called blind spots that limit scientific progress and innovation. So, the intersection of AI and scientific discovery presents a great potential to reshape how research is conducted and new knowledge is generated. With this perspective in mind, let's explore how AI can accelerate and improve hypothesis generation. To begin, I'll briefly discuss the taxonomy of AI methods for hypothesis generation. And this was proposed by Liu in 2024 paper. So basically, they noticed that the current methods for autonomous hypothesis generation can be roughly divided into three categories: literature-based, data-driven, as well as a hybrid approach that blends these two. So famous example of literature-based method is Swanson discovery. He identified a previously unnoticed link between fish oil and Raynaud disease, and he did it in the 80s by manually analyzing two disjoint bodies of literatures. It's incredible to think how much more we can actually achieve right now with all the AI tools we have at our disposal. So, what are the benefits of such approach? Well, they are grounded in scientific facts and they are theory consistent because they're based on them. There are also risks. For example, hypotheses generated in this way may propagate publication biases, and they may also have difficulties moving beyond the paradigms they're operating in. And this brings us to another approach, so-called data-driven methods. These methods derive hypotheses by identifying patterns, correlations in empirical data. A good example here is discovery of hallucination. So MIT researchers employed deep learning models and algorithms to go through extensive chemical libraries, basically pinpointing hallucin as a promising antibiotic candidate. The data-driven discovery excels at identifying novel insights and patterns hidden within extensive data sets. However, there are also limitations to this method. For example, they might be overfitting and they lack explainability. And in contrast to the method discussed on the previous slide, they are not grounded in scientific literature and they are not theory consistent, or they not necessarily need to be. And this brings us to a hybrid approach that basically merged the best of two worlds. empirical data analysis, and literature mining. So you can imagine leveraging large language models to generate new hypotheses that are based on the patterns observed in data, but at the same time, grounding these insights in established scientific literature and knowledge. This powerful integration allows for hypotheses that are both innovative and scientifically robust, accelerating the path from discovery to understanding. We stand on the shoulders of giants signifies our reliance on past breakthroughs. And over the next few slides, I would like to mention fundamental papers that greatly influence our approach to building BeeARD's autonomous discovery system. The first paper I would like to mention is The AI Scientist by Sakana AI. They aim to create a fully autonomous researcher, an end-to-end entity that is focused mainly on machine learning research. They have also recently announced the acceptance of the first AI-generated paper at the peer-reviewed conference, marking a small step for science, but a giant leap for autonomous scientific research. Another fascinating paper comes from MIT, where the researchers leverage random path traversals within the knowledge graph to uncover novel and interesting research directions. They employed subgraphs as input representations for multi-agentic system as their prompts, something that we use extensively in our approach at BeeARD. Finally, Google's co-scientist paper, where they allowed for extended thinking with increasing test time compute. And this was remarkable achievement because the results they got were later also experimentally validated, pointing that in increasing the time to think for the models about a specific problem is a very promising approach. So all of these papers led us to what we are building at BeeARD. We are on the mission to accelerate science by generating and validating new ideas at scale. But this part is important because generating hypotheses is only half of the story. Our project is also focused on validating these ideas, closing the loop in scientific discovery process, because we want to ensure hypotheses aren't just possible, they are also truly valuable. In our approach, knowledge graphs serves as the central backbone underpinning what we call infinite discovery, a continuous and scalable exploration. And why do we use knowledge graphs? Well, first of all, knowledge graphs are a great structured representation of data, and they can also limit AI hallucination by grounding them in facts. They also, due to their structure, allow for multi-hop reasoning that even further increases abilities of AI agents and also increases the explainability of the insights derived from these agents by linking nodes and certain concepts back to the literature they were derived from. So here I would like to spend a little bit more time because subgraph is fundamental to our approach. And I would like to propose you this metaphor to think about the knowledge graph as a network of thoughts. In this context, a subgraph is like capturing a chain of thoughts, a meaningful sequence of ideas connected by a relation. And why subgraph matter? Well, because they reveal how ideas are connected and interconnected. Subgraphs can act as focused snapshots of thinking. They also act as sparks of inspiration for the multi-agentic systems, prompting the generation of novel scientific hypotheses. I love this tweet by Andrei Karpathy. And in this tweet, he described LLMs as alien artifacts. And if you think about this, with billions of parameters these language models have, there are basically countless ways one can poke them, yielding diverse and unexpected insights every time you poke them differently. This is exactly the concept fueling our exploration. And here I would like to show you some examples of how to poke these language models. So we have developed algorithms that allow our agents to traverse through knowledge graphs. And they can do it completely independently, generating unique and creative subgraph paths. And we can achieve it due to randomness. We basically randomly select a starting node and let the agent decide where to go next. Basically, feeding it with a list of neighbors it can go to, and also the path it already covered. So all of these journeys these agents take are distinct. Each of these journey provides fresh scientific insights, and it's not only shaped by the facts in the knowledge graph, but also by the model's parametric knowledge and the structure of the language model. And over the next slides, I want to present you these journeys, stories, if you will. And all of them are generated by our agents traversing through the knowledge graph. As I mentioned before, we treat subgraphs as sparks of creativity. This allows us to tap into the deep knowledge encoded within large language models as they are being trained on billions of tokens. All of these stories are being used then as inspiration for multi-agentic systems that are tasked with scientific hypothesis generations. They are the sparks of inspirations for them. And because of this, all of these subgraphs, all of these stories become stepping stones toward infinite discovery. But why generating hypotheses in this way is so powerful? And at the same time, why is it so challenging? Well, in knowledge graphs, concepts and their relations lead to an explosion in possible paths. The complexity grows rapidly, highlighting why efficient exploration methods are essential. So, how do we then reason through this combinatorial chaos? And what are the methods that let us separate insight from entropy at scale? Well, welcome to HypeGen. HypeGen reimagines knowledge graphs into dynamic, evolving organisms. This is a living network of ideas fed by human input, enriched by autonomous agents, and also shaped by real world scientific breakthroughs. It's not just data, it's living knowledge that learns and grows with us. In HypeGen, each hypothesis and subgraph becomes a living social artifact on the AT protocol. Every idea is open to critique, comment, and collaboration, transforming individual insight into shared growth. With every interaction, the system refines itself, learning from the feedback it receives. So, knowledge is no longer static, it's alive. And this project is being created in collaboration with Coordination Network, and we are preparing for takeoff. So more information is going to come soon. Stay tuned. Thank you so much for listening, and good luck on your journey through this hackathon.